Alright, this is Paleac, and we're going to talk about sound design, in particular making trippy, psychedelic, squelchy basses and stuff. All the like glitch hop, side dub kind of sounds that you've been hearing from like Tipper and other producers in that field, Resonant Language, Detox Unit, etc. So to start, we're just going to take a sawtooth wave. It doesn't matter if you're using Serum or not. I'm just using Serum because I like the pitch bending controls, which are pretty important. So let's just bring that down a bit. Honestly, it doesn't matter. And so the formula for making a squelch is simply pitch bending and some form of form and filter. Or you can create a form and filter by using multiple bandpass filters. So we're gonna create a mapping for the pitch bending so we can automate that, right? And then we're gonna add some bandpass filters. So we'll get an auto filter, 2 auto filters, actually. And then what we're gonna do is we're gonna run them in parallel, right? So set them both to bandpass. And now you can get some kind of squelchy sounds, but let's add some pitch bending as well. Something like that. I don't know. Right, so we have that as the pitch movement, and then we'll move these around in some wacky way. I don't know, something like that. Right, just drawing automation doesn't matter. We'll move this one just a little bit more subtly underneath. Right, so we got, oh god, that hurt. We have, okay, so there you go. You have some squelches. You can add an arpeggiator so it like starts playing it as a beat. Put on like swing mode or something. Right, that's fun. Now, the issue with this is it is extremely tedious. We drew 3 lanes of automation just to get the sound, and it can take a while and a lot of fine-tuning to create the sounds that you want. So the next step is we are gonna do this again, but instead we're gonna use randomness to control everything for us, right? So let's create a little audio effect rack, and then we can take all the things that we want to map. So like let's add the resonance as well. Do frequency, resonance, and then find an LFO. Able to LFO. Let's set the LFO to random, and then what we're gonna do here is we're gonna create another audio effect rack, and we're gonna take all of the parameters that we're probably gonna play with. We're gonna add them to here, right? And then we're gonna duplicate the LFO. Now, when I adjust the rate on one, I adjust the rate on all of them, and so I can assign them to different things, right? And so here, let me close that, we can map the frequency of each thing from the resonance. Now the resonance, if it gets way too high, it's not going to sound good because these are bandpass filters, right? So, we don't want it to look like that. That's going to destroy the sound. So we just lower the max of the resonance, something like that, Now let's add smoothing. And then, oh yeah, we need one more for pitch control as well. And then you can use this to adjust the range using the max and min of where you want the pitches to be. Right, and there you go. It spits out all the squelches that you can want. So let's record some of these first, and then see what we can do with that. Right. Okay. And now taking this, you can do some like time stretching and pitching. And so you can, like, you know, cut these up and use these as like one shots or something. All right. Now there is one issue with this sound, is it can hurt your ears a lot when, let's say, both auto filters are in the like 1 to 5 kilohertz range, because that's the hearing range that hurts us the most, because babies cry at that frequency or something like that. It's like an evolutionary thing. Basically, high-pitched stuff hurts our ears, right? So something you can do to avoid that issue of every time the auto filters line up in that range, it creates a headache for mixing. Trying to mix down these sounds can really suck. So something that you can do is you take an EQ8, right? We're gonna do the same kind of thing for the EQ8, but instead we're gonna use band reject filters like this, right? For 2 of them. And then what we're gonna do from here, we're gonna create another chain, and we're gonna run in parallel a phase inverted version of the previous, of the input signal, right? So the phase inverted version and this, when you play them together without the filtering, you hear nothing, right? Because they're canceling out completely from the phase inversion, right? And then when you have this playing, what you're going to hear only is the difference between the 2 signals, meaning these 2 things. So it's going to actually only play what's being taken out, which in effect is a bandpass filter. And the benefit of this is now when both bandpass filters are overlaying each other, instead of adding together and creating a really high resonant peak and hurting the shit out of your ears, you only hear one. They just cancel out. Now, there are differences in like the timbre of the sound because of how the filter algorithms work. So there is going to be a difference, and also like them adding together and being super loud when they cross over each other can sound cool depending on the sound you want. So I'd recommend trying both different methods, but this is something else that I found to be very useful, especially for mixing and stuff. So let's do the same exact thing, but instead let's map this also to the frequency of that one, and then we'll map this LFO to the frequency of that one, and then we'll map the LFO that controlled the resonance to the Q, right? Let's slow down the rate so we can see what's happening a little bit more, add more smoothing, right? And then let's do the same thing. We do the resonance to, oh god, can't click on it because it's moving around here, to the Q of this one, right? Now they're moving around a lot. Let's increase the range, because I don't, if the Q's all the way down, you're gonna hear too much of the sound, right? The distance everywhere is gonna get taken into effect. That made sense. All right. So basically, I'm gonna have generally a high Q. It's going to go between about 50 and 100%. Well, I don't want it to be too high, so let's go 50 and 80. Right? Okay. So now this is with the band reject filters going into a phase inverted version, sounds like. And then this is what the other one sounds like. So like this one, to me, sounds like it has a little bit less character. It sounds a little bit more muted, I guess. But it sounds nicer. At least like it doesn't hurt as much. It's not as harsh, right? And so if you're having issues with mixing these sounds, if you have Soothe, which is albeit pretty expensive, it's like over $200, I think. Soothe is pretty good to deal with these because it is a dynamic EQ suppression thing. So whenever the frequencies add up together, it's going to light them for you. But it's not perfect, and it takes a lot of fandangling and shit to figure out, right? Okay, so those are the two different main ways I use to make squelches. Now, the problem with using LFOs to control everything is that you basically will make a sound and record it, and then you're stuck with that sound. You can't really go back and edit, let's say nudge one of the bandpass filters around or change the coarse pitch movement of the sound. Like if you like how the filter sounds, you know, like if we take this, like let's say I really like that and I want to use it again, but I want to like change the filter movement so that it's playing like different sort of formant vowel sounds but the same pitch movement. You're limited in that regard, right? So this is where my favorite Max for Live device comes in handy. It's called the Hypnus Spellbook. Alright, this is another recording because after that last part that you saw, I started just kind of rambling a little bit and poorly explained everything. So let's try again. Alright, so my secret sauce to all of my sound design lies in this little Max for Live plugin right here called the Spellbook. It's by Hypnus Records, which is a record label for hypnotic techno. They are fucking awesome. Highly recommend you check them out. And I believe it was designed by the owner of the record label, who goes by N-Togen or something. Not sure how it's pronounced. But I'll have links in the description for everything. The device is like $25, I think. Maybe a little bit more, maybe a little bit less. And it's 100% worth it. I've been using it for pretty much every production of mine for the past like 2.5 years. It is extremely deep and surprisingly complicated. Oh, I didn't mean to click that. Yeah, it's how the fuck do I close this? Help me. Okay, and it is essentially a two-dimensional multi-mapping LFO. So what it does is you can map things to the x-axis and you can map things to the y-axis, and then you can have them control different parameters, and then as this little dot moves around the shape that you designate, it's going to move those parameters around in that fashion, right? So let's say we'll map it, the x parameter, to coarse pitch. Notice as x is going across this, the pitch is going up, right? Let's turn this down. Cool. And now we want more to be done. Let's map the y parameter to frequency of one of the bands. And then here you can control offset. Let's say I don't want the frequency to go below like 200 or so, because there's not that much there, or I guess below 100. You can lower the offset. You can lower the range of frequencies that it goes through, and then you can move the offset around to designate where along. So if it's up here, obviously this is going to be mostly in the higher range. I'll also link videos giving a more detailed explanation of how the device works. But basically what we're going to do is we're going to create multiple mappings to the different bandpass filters, and then we are going to change how they're being read. So if you hit them ×2, it's going to start reading through it faster, right? So this is going to create an entirely new mapping system. So my understanding is that in the time it takes for this to make one entire revolution and go around its entire LFO pattern once, this one does it 8 times. So now there's like a polyrhythm almost of sorts. And you can do that with everything. And then you can also change the direction that it's reading. So instead of going from left to right, it'll be inverted, so it'll be right to left. So you can do this with all the stuff. And essentially what you're going to do is you're going to have all these different knobs following different LFOs that are all controlled by the location of this dot on the shape. So let's map to resonance. Let's lower resonance as we did before because we don't want it to be too loud. and see how we get. And then let's record some of that. Alright, that's something. And we can take this recording, and then you can modify in all sorts of ways. You can pitch it up and down. You know, all sorts of cool stuff. Something that's great is you can use an auto filter. There's built-in LFO. Turn this up. Honestly, you can put this on just this thing. Turn up phase. Alright, that's cool. So you can have this kind of just running, and it creates this cool pattern. You can adjust the read rate, where you can change spin, and then the entire shape starts to spin. Change the shape of the actual shape itself. I find the hexagram to be the most interesting. We can add an arpeggiator so that instead of it just being a constant signal going up and down, you get kind of a beat. Now let's put some compression on there, because with these really dynamic movements created from the bandpass filters, you get a lot of dynamics and quiet parts, and then if you compress the hell out of it, I like to use the flatline multiband compression preset. It just slams everything. Get some cool sounds, right? Cool. Alright, and now there's more to it than just this, of course. I recommend playing with this and just throwing any effect that you could think of on here. Echo delays are really cool for repitch delays. Honestly, I'm going to do that right now. Let's get a delay. And then, yeah, let's just unchain these, and then, oh, whoops. Map right and left to different things. Let's just mix everything up. I mean, that's cool. Alright, you get the point. You see great sounds from this, and then you can further modify them. There's this one I thought was pretty cool. You could like turn that into a riser or something, probably, right? Have that like pan around or something cool way. Anyways, yeah, so you create cool sounds just by mapping shit to the spellbook. What's also very interesting and very powerful is you can turn off read mode, so it's on hertz, right? Or on on beat. It's synced. It's synced to the grid. And then let's hit reset to reset the position of all this stuff. And so what's powerful about this is every time you play this, it's going to play the exact same pattern. So now you have control over the sound, even though it's like pretty much randomly generated from the shape, right? Because I mean, we're not able to predict exactly what it's going to do based on where it is on the shape, because there's all this crazy LFO whackery going on. So what's powerful about this is you can also automate the offset for the read itself. It's going to play the same sound every single time, but like let's say I don't like that sound right here. I can move the read. Let's turn off the delay. Now, I kind of like how that sounds. So now you have like a fucking beat. That's cool. Now, you'll notice, I mean, as you keep playing, it'll keep changing as this thing rotates. I mean, we're nudging the offset, but it's still reading and spinning the entire time, so it will constantly transform, and you won't be able to, like, repeat the exact same thing. But if you want to fix that, you can do is you can set read to off and spin to off. Reset everything. It's going to do the same thing every single time. And then you can manually automate everything. Alright, so this is an example from a song I've been working on recently. It's essentially doing the same thing, though it's quite a bit more convoluted. I have one spellbook that's controlling the frequencies and resonances of two auto filters, or bandpass filters working in parallel. And then I have a second spellbook that's just controlling pitch. And so I have knobs that control hyperparameters regarding the pitch controlling spellbook and the filter controlling spellbook. So I basically have it set so that when I move the input knob all the way from 0 to 100, it only scans over a smaller region. And I can use these knobs to designate what that region is. If this is set to 0, it doesn't scan at all. If it's set to just a little bit, it scans through a small region. If it scans all the way, it scans through a much larger region. And then there's also this offset knob that lets me choose which region area it's going over. And so essentially all of these knobs dictate what the random quote-unquote seed is of the spellbook. So I can, it's like pseudo randomness in effect. I'll have kind of pretty much random sounds coming from moving this input knob, and then I can modify which of those random seeds are, or random sounds, by adjusting the seed, and I could do it incrementally to have the sound transform gradually with intention. But basically, this is what it sounds like. Just listen. You'll obviously there's a shit ton of automation. I mean, this did take a little bit. I had to fine tune a lot of stuff, but I find it much better than actually manually working with, you know, filters or working with just raw audio and having to make do with the sounds that you have. Being able to adjust them is super powerful. So for instance, say I don't really like how that sounds. I can just move the spin offset. Move pitch. Increase the pitch range. So you can see how that's like super powerful. You can create variations of different sounds and modify them in just really cool ways that you can't really do otherwise. Yeah, I hope that was helpful. If you have any questions or comments or just suggestions for how I can make the tutorials better, if I make any in the future, that would be greatly appreciated. And yeah, I say go buy the spellbook item. And I mean, you don't necessarily need to. I'm sure there's ways you can emulate the same kind of thing using like multimappers or something. Like I'm sure there's a bunch of free Max devices that you can use and chain together, but I heavily recommend this one. It's so fun to play with and just mess around with sound design, and I'm sure I'll probably be making more tutorials in the future just diving into what you can do with this. Like you can change, for instance, where what the read offset is for any parameter, and then so you can like be controlling the locations of multiple different objects in regards to 3D space with this shape. It's cool. Anyways, yeah, I hope you enjoyed and you learned something, or you felt inspired, and you're gonna go open up your DAW and make something cool.